Hey guys, it's Mr. Sheelan here. This is going to be a video that is just a video walkthrough, particularly pertaining to Unit 6.3, the Stoichiometry worksheet number 3. So I'm just going to be walking through number 1, number 2, and then number 3 as just extra help, that extra little nudge you need in order to remember, keep you on the right track when it comes to solving this material in these styles of problems. So make sure that when we're completing this worksheet though, you're going to show all your work. And not only that, make sure, and remember, I don't grade this, but it's super duper important that we write out every little bit of information about every little step that we're doing. So that means units, that means compounds, that's elements. Make sure we include everything in each conversion factor that we're using. Okay. So now this one's going to be a little longer because I'm actually going to be finding molar masses on the fly. When normally I have it prepared, I'm just going to do it to show you, I guess, to show you guys, this is how I find them, and which is nothing different than you've seen. It's just I'm just going to do it all, in real time. So, okay, so it's going to be a little longer because of that. So how many moles of oxygen are necessary for combustion of 134 grams of magnesium? And then here's the reaction. So it's asking, well, how many moles of oxygen do we need in order to combust these 134 grams of magnesium? Okay, because remember, like I've mentioned, is that we only have so much of both stuff, and there's always just for every 2 magnesium, we need 1 molecule or 1 mole of oxygen to combust and to form magnesium oxide. So we just want to see, well, how much do we need to perfectly fit with the amount that we're putting in for magnesium? So, okay. So here, let's first establish where we're starting. And it says here that we're starting with 134 grams of magnesium, so 134 grams of this stuff. How many moles of oxygen are necessary? Well, how many moles of oxygen? That's all I care about. So how many moles of oxygen are we going to calculate? Okay, so we're starting here, we're ending here, okay? Starting here, ending here. So I've got to convert from this to this. Grams or mass of substance A to moles of substance B. So I'm just going to write out 134 grams of magnesium. And I've got to convert 134 grams of magnesium to moles of magnesium. So I'm going to use the molar mass here. And so it's 1 mole of magnesium on the top because those are the units I want to convert to, while the old units are going to be grams of magnesium. I'm going to look at my periodic table, and I'm going to see that magnesium is just this easy peasy 24.3 grams. Okay. So if this were to cancel, that cancels, that cancels, that cancels, I'd be left with just moles of magnesium. So mass of A to moles of A, now I got to go from moles of A to moles of B. Okay, so that means my old units are going to be moles of magnesium, while my new units are going to be moles of oxygen. Okay. Well, this is where we're going to use the coefficients. What's my molar ratio? Well, for every 1 mole, and it's 1 because there's nothing in front of the O2, for every 1 mole of oxygen, I have 2 moles of magnesium. Okay, and I want to double check to make sure, let's see, those would cancel, that would cancel, and I would just be left with moles of oxygen. So all these other moles, grams, and compounds / elements all cancel out, so I'd be just left with moles of oxygen. Okay, so it's going to be moles of O2. And if I put that in my calculator, I can find a good spot here, that's good. So it'll be 134 times, actually I'm going to put it all in one. 134 divided by 24.3 times 2. And it looks like I will get this as my number. I'll get 2.7572, blah, 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 blah. Now, what's my answer going to be? Well, my answer needs to keep 3 sig figs. So looking at this guy, it looks like my answer should be, get a good spot, 2.76. I think that's going to be, I don't think I know, 2.76 moles of O2 is my answer. Okay, so I kept sig figs, I've got the right units, and I've got the right compound labeled here, because we ultimately wanted to know how many moles of oxygen we needed in order to combust with 134 grams of magnesium. Okay. All right, let's take a look at number 2. Find the mass of aluminum required to produce 4.72 moles of hydrogen gas from the reaction described by the following equation. So here's my equation, all this good stuff. So let's figure out what we're working with. So find the mass of aluminum. So it looks like we want to know the mass of aluminum required in order to produce. So it sounds to me like mass of aluminum. If I didn't know where that was, well, it's saying here, find the mass of this stuff required to produce. So it sounds to me like we're wanting to know how much aluminum are we adding here. So that tells me it should be on the reactant side. And it looks like aluminum is. Looks like we're going to end here. Find the mass of aluminum required to produce 4.7 moles of hydrogen gas. Okay, so here it says that this stuff we need to put in order to produce, and it says here to produce this stuff, so it tells me that this right here should be a product. So I look over here at my products, and I see I've got hydrogen gas right here. It looks like I'm starting here, and I'm ending here. Okay. All right, now 4.72 is the number that we want to reach in this case, because we want 4.72 moles of hydrogen gas to be produced. And we want to know, well, if we want that amount of hydrogen gas produced, how much aluminum do we have to toss into the system? How much aluminum do we have to mix with this? That's a sulfuric acid here, sorry. How much aluminum do we have to add to sulfuric acid? Okay. So my old units are going to be moles of H2, so I'm going to put moles of H2 down here because I'm going from moles of substance A, and now I got to go to moles of substance B. Okay. And so my new units are going to be moles of aluminum. Well, I'm going to see what the molar ratio is between these two, so it looks like there's 3 moles of H2 to every 2 moles of aluminum. Okay, so now I went from moles of A to moles of B. Now I got to go from moles of B to, it looks like, mass of B. So my old units are going to be moles of aluminum, because I got to get rid of those, and my new units have to be grams of aluminum. Okay, and we all know that we've got to use molar mass here, so in every 1 mole of aluminum, looking at my periodic table, there are 27.0 grams of aluminum in every 1 mole of aluminum. Those would cancel, this would cancel, and I'd be left with just grams of aluminum. And then let's pop that into the calculator. So that's going to be 4.72 times 2 times 27.0, all encompassed in one big old, here, I'll zoom in on the calculator, by the way, so you can really see it. So you notice all these parentheses. Not only am I keeping each number distinct, I'm also keeping this whole operation distinct as well with those outside parentheses. I want to multiply everything up top first, then I divide, and it's just going to be divided by 3 because it's just 1 times 3 times 1 on the bottom. And it looks like what I'll get is 84.96. Okay, now looking at my number of sig figs, though, that I'm operating with here, it looks like we're operating here with just 3 sig figs. So 84.96 looks like if I were to keep sig figs, first I would see, well, maybe it's 84.9, but there is a 6 next to the 9, so that 9 has to be bumped up. And so actually the answer is going to be 85.0 grams of aluminum. Okay, so again, there's a 6 next to that 9, so that means that I round my 9 up, because this has to all be just 3 sig figs, And when I round my 9 up, it's going to change this from 84.9 to 85.0, which is exactly what I have here. Okay. And then lastly, we're going to take a look at number 3 here. How many molecules of hydrochloric acid are required to completely react, I should say react with 225 grams of iron according to this following equation? So just by reading this, I can already see that we're looking for particles of hydrochloric acid, and we're going to start off with 225 grams of iron. Not only that, it's saying that this stuff should react with this stuff. So this is telling me that these are both my reactants, which it looks like they are. Here's iron, and then here's hydrochloric acid. And I'm going to be starting here, and then I'm ending here. Starting with mass of iron, and I want to go to particles, specifically molecules of hydrochloric acid. All right, so we're going to write down what we start with, what we're given, which is 225 grams of iron. So I got to go from mass of A to moles of A. So here it looks like I've got to do this. So it's going to be, I'm going to put my new units up top, my old units on the bottom. And I know this is going to be the molar mass. So in every 1 mole of iron, looking at my periodic table, I'm going to have 55.8 grams of iron for every 1 mole of iron. So this would cancel, and I'd be left with moles of iron. So I went from mass of A to moles of A. Now I got to go from moles of A to moles of B. Okay. So my old units go on the bottom. My new units go up top, and it's going to be hydrochloric acid. This is where I'm looking at molar ratios. So it looks like for every 1 mole of iron, we need 2 moles. We're going to use 2 moles of hydrochloric acid. This cancels, that does, that does. We're left with moles of hydrochloric acid. Now I went from mass of A to moles of A to moles of B. Now I got to go from moles of B to particles of B. So old units go on the bottom here. So moles of hydrochloric acid. And this is going to be Avogadro's number. So that means that for every 1 mole of hydrochloric acid, we have 6.02 times 10 to the 23rd molecules of hydrochloric acid. That cancels, this, and I'm left with just molecules of hydrochloric acid. My answer is going to be plopped down there. So now I'm going to pop this into my calculator, this big long equation. I'm trying to find that magical sweet spot so you can really see my calculator. Okay. So I'm trying to keep that glare out. So that's going to be 225 times 2 times 6.02 times 10 to the 23rd. And that's going to all be locked up because that's my entire operation on the numerator up top, divided by, it looks like it's just going to be the 155.8. And I pop that in and I get here 4.85483.871 times 10 to the 24th power. Now, my answer though needs to be in 3 sig figs because I start off here with 225. Okay, so ultimately my answer here is going to be 4.85 times 10 to the 24th power molecules of, it looks like, HCl, hydrochloric acid. And then I would have my answer there. Okay. All right, so that's just going through number 1, number 2, number 3 to kind of get back into the swing of things for that extra help. Keeping sig figs, making sure that we are tracking every little bit of information here, showing all the different moles of the different substances, establishing where we're starting and where we're ending, understanding what the question is asking here, okay, everything. So I hope this helps you guys. If you still need any more help, if there's anything that you still don't understand when it comes to stoichiometry, make sure you reach out to me, make sure you ask. But if not, I'll see you guys in the next one.